In section 2.5, we're going to be dealing with scatter plots. Really, a scatter plot is a graph that is comparing two different things and showing you the data in ordered pairs. So I'm going to explain scatter plots by showing example 1. So problem number 1 here says that the table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. We want to make a scatter plot, and then we will describe the correlation. So there are a few things that you need to have in a scatter plot before you ever put data on it. One of those things is a title for the graph. You got to know what the graph is going to be. So the data that's given to us already has a title, and so we're simply going to use that as the title of our scatter plot. So we have average temperatures and electricity costs. All right, so that is our title. We also need to label our X and Y axes. So first off, we have actually 3 pieces of information here. We have a month, average temperature, and electricity bill. So we've got to decide which 2 are we working with. Well, it just so happens that we're dealing with average temperature and electricity costs, so our title actually told us which 2 to work with. So we know we're going to use average temperature and electricity costs.
Come to the office. Kyle Densing.
We then need to go through and decide which one goes on the x-axis and which goes on the y-axis. So to do that, we got to know a little information. The x-axis is always the independent variable. And so then the y-axis is the dependent variable. So what that means literally is that the x-axis is things that can stand alone. For example, time is a good example of an independent variable. Time is independent of any other outside forces. Okay, we can't change time. And so if we look back at our data, we're dealing with temperature and electricity costs. Well, we're talking about outside temperature here. We don't control that. Mother Nature does. So average temperature is then going to be our x-axis. Making our y-axis, or dependent variable, the electricity cost. Okay, the next thing we need to do for our scatter plot is we got to decide the scale. Okay, the origin is always sitting here at that crosshair. Okay, we're only zoomed in on the first quadrant of our coordinate planes. And so 0, 0 is right there where the 2 axes cross. And we want to go ahead and graph all of our data, and we want it to fill the space provided. We do not want all of our data just down here in one little corner. So what we're going to do then is we need to look at the data given to us and decide what our range is. So for example here, in the temperature, we have the lowest temperature is 58 degrees. The highest temperature is 85 degrees. So I'm going to make sure my range covers those values. So I'm going to say let's round it down to 50 degrees and let's round it up to say 100 degrees. So I'm going to go ahead and skip ahead in my graph a little bit. So there's going to be 50, and I want it to go to 100. So if I look here, I've got lots of spaces here. I counted before I started this problem, and I have roughly 30 spaces. So that means I can go through and have each little hash mark count as 2 units. Okay, or in this case, 2 degrees of temperature. So if I go ahead and start counting here, I've got 2, 4, 6, 8, this is going to be then 60. And I can keep going across. So now I have my x-axis scale done. We need to look at electricity costs now. And from the electricity costs, looks like our cheapest month is December at $110. And our most expensive month is July at $255. So again, I want a range that is going to cover that those costs. So let's round it down to 100. Let's round it up to 300. So looking at my graph again, I'm going to skip up to here and have that be 100. And I want to go ahead and I believe there's 20-some, maybe 25 marks here that I can work with. So let's go by tens. So 10, 20, 30, 40, 50. This is 150, and I'll go ahead and continue on my scale. So now I have my Y scale done, going by tens. Now, one issue I have here is in this region down below, I went from 0 to 100 in 2 spots. That means that each spot here must be 50. But wait a minute, up here I had them all going by tens. Same thing on my x-axis. Each spot here is 25 because I go from 0 to 50. But I had each one going by 2s after that. So I have a jump or a break in my graph. And I have to indicate that by doing a little zigzag line here. That shows everybody that, hey, there's a jump in my data. And I can't have that jump anywhere other in my graph other than right at the beginning. So I'm kind of zooming ahead to where my data is rather than trying to have 0 to 50 on my graph with no data. So over here, I also draw a break. So I've got a break on the y-axis from 0 to 100 and a break on the x-axis from 0 to 50. And now I've got my graph set up and ready to put data on it. Okay, so to put data on the scatter plot, we simply go back to the graph given to us, or the information given to us, and we now graph these as XY coordinates. Remember, our average temperature was the x-axis, and our electricity bill was the y-axis. So we would have an x-coordinate of 61, a y-coordinate of 150. And we go ahead and look at our graph, and we go to where 61 is on our graph, and 150 gives us a data point right there. And we continue on with the rest of our data. Okay, so now we have all of our data points graphed on our scatter plot. We can now see that all of our data is kind of going in this direction. Okay, it's traveling up from left to right. So that tells us that we have a positive correlation. If we look back at our notes here, we have positive correlation right here. Think of like positive slope. That's the direction of positive slope, so we call that positive correlation. Over here, this is the direction of negative slope, so that is negative correlation. And there can be no correlation sometimes if the data is so spread out that we can't really see if it's traveling in a positive or if it's traveling in a negative direction. So our data here, average temperature versus electricity cost, gives us positive correlation, which tells us as the temperature increases outside, our electricity cost increases, which kind of makes sense when you think about how much you run your air conditioner in the summer months. We also then want to talk about correlation versus causation. Think cause and effect. So correlation and causation, if we look at our graph, we know that there's a positive correlation, but do you think that there might be a causation here? Well, if you're talking about average temperature outside and electricity costs, there is probably a causation as well. Again, think about your air conditioner. As temperature outside goes up, we tend to turn up our air conditioner, and it runs more, therefore costs us more money on our electricity bill. But also think about maybe if we did a different graph where it was students at Bellevue, in the Bellevue School District from kindergarten through high school and their reading ability. So if we did a small little graph over here of height versus reading ability from kindergarten to high school, we would probably see a positive correlation as well. Okay, because think about your height when you're in kindergarten and your reading ability versus your height when you're in high school and your reading ability. Obviously, you guys read better than kindergartners. But is there a causation between these two items? Does height make you read better? Well, hopefully you're thinking to yourself, obviously not. Otherwise, we'd be buying stilts for kindergartners a long time ago. Okay, so causation and correlation do not mean the same thing. Just because there's a strong correlation does not mean there is also a causation between these two items.